Another example. You're saving for a new house and you put $10,000 per year in an account paying 8%. How much will you have at the end of 3 years? A. The payments are made at the end of each year. B. The payments are made at the beginning of each year. Let's see if it makes any difference, and if so, how much of a difference. Cases A and B are illustrated here. Again, each has its own little timeline. In case A, where the payments are made at the end of the year, the first $10,000 is at the end of year 1, and then we have 2 more after that. In case B, with payments at the beginning of each year, everything is 1 year sooner, right? So if between 0 and 1 we have the first year, then the beginning of the first year is under 0 on my timeline. This is where we have the first $10,000. Everything is sooner in case B, right? In both cases, A and B, we are asked to find the future value, right? How much you will have at the end of 3 years. So we need to find the combined future value of these 3 numbers at the end of year 3 in both cases, A and B. Okay, so let's calculate case A future value. Following the standard formula that we had many times, you would use 8% for the interest rate per year, which is given, and 3 for the power in the formula. And 3 indicates how many repeated cash flows we have. So we are making 3 deposits, and that's going to be the power in the annuity future value formula. The answer we get is 32,464. And of course, we can do it in the financial calculator. First, turn the calculator on. Let's clear everything, which is always recommended. Second, plus minus, enter. $10,000, make it negative, press payment, PMT. 3 is how many of those payments we have. So I press 3N. And the interest rate is 8%. I press 8 IY. And I'm gonna compute future value. $32,464 even. Right? This is the same calculations we were doing in all previous problems. And now the second case, case B. Let's see what's going on here. Everything is 1 year sooner, right? Do you think it makes a difference for the combined future value? Of course. Every single one of these $10,000 cash flows will earn interest over an extra year, right? So the very first deposit will sit in the account for full 1, 2, 3 years, as opposed to case A, in which the very first $10,000 will earn interest over only 1, 2 years, right? And so on. And so a much easier way to find the future value for case B is to take the answer from case A, which we already have, and add in 1 year worth of interest, right? There is 1 extra year over which the cash flows earn interest, every single cash flow in our annuity. So we take $32,464 and multiply it by 1 plus the interest rate, which is 1 plus 8%, or simply times 1.08. And we get $35,061. This answer is higher than the answer in part A because of the extra 1 year worth of interest that all 3 of our deposits will earn. And what we did in this step, in the financial calculator, the way you would do this step is, let's clear everything first. you would take the answer from part A, which is behind the calculator. That's $32,464. Make it negative and set it as our present value, PV. 1 year later, right? What's the future value? 1N at 8% annual interest rate. 8 IY, compute future value. $35,061, and actually there are 12 more cents in the answer. In finance, we refer to cases A and B as an ordinary annuity and annuity due, respectively. An ordinary annuity is like an ordinary case, the standard, most typical case that we deal with. For example, a lot of problems don't actually specify when the payments are made or received, at the end or at the beginning of each time period. So if it's not specified, the default is at the end, and that's the ordinary case. That's an ordinary annuity. But the warden might give you a hint that the payments are at the beginning of the year. So maybe they say something like the first payment is going to take place immediately, or the first payment in our annuity is today. Or it could say payments are made at the beginning of each year, kind of very clearly. That's an annuity due. So the first payment is due immediately. And in the calculations you see here, the way we adjust for the beginning of the year is we take, the regular annuity future value formula and multiply it by 1 plus the interest rate, right? So we are adding 1 more year worth of interest to every, single cash flow. So just to review, annuities can be called ordinary or due. Ordinary annuity and annuity due. Ordinary annuity has payments at the end of each period, and annuity due has its payments at the beginning of each time period. You can also rephrase and say that in an ordinary annuity, the first cash flow occurs with a delay. So you have to wait 1 time period before you have to pay or receive the first payment, depending on the problem. And in an annuity due, the very first cash flow in that annuity is immediate. And this is the general formula which shows how we can go from an ordinary annuity future value to an annuity due future value. We simply multiply by 1 plus the interest rate. And so you can say that the future value of an annuity due is always going to be a bigger number than the future value for an ordinary annuity. That's because of this 1 plus R term. But there is another way to find the future value of an annuity due. In the problem we just did, right? We can do the following. Let's clear everything. We can tell the calculator that the calculations I'm about to do for an annuity are going to be based on an annuity due, right? And you press 4 keys. Second payment, it brings up the text right above the key payment that says BGN, begin, and then second enter. So basically you're saying begin set to the begin mode. And then you can even turn the calculator off and back on. Now the display shows 3 extra letters, BGN, begin. Everything is now in the begin mode. And now, after setting the calculator to the begin mode, I want you to do what you did for an ordinary annuity, right? you did what? You did 10,000, make it negative, PMT. We have three of those, 3N. 8% is the annual interest rate. 8 IY, compute future value. What do we get? We do not get the answer for case A. We get the answer for case B. Annuity due answer, $35,061.12. So this is probably going to be your favorite method, right? So to summarize, there are, how many methods do we have? I would say three. One cash flow at a time. So the first $10,000, find its individual future value using 3 years, right? The second $10,000, find its individual future value after 2 years. And the last $10,000, find its individual future value after 1 year. And then add up the three individual future values. That's one, kind of the most time-consuming method. The second one is what I have on the slide, where you first calculate an annuity future value, but the default in the calculator is that everything is at the end of the year rather than at the beginning. So it will not give you an accurate number. And you need to then, as the second step, need to make an adjustment yourself. You take the number you got and multiply it by 1 plus the interest rate, 8%. So this on my slide is basically the second method. And the third method is where you set your calculator to the begin mode, second payment, second enter, and then do what you did for an ordinary annuity. Because the financial calculator will know that this is not an ordinary annuity that you are doing the calculations for. It's an annuity due. Okay. Then next, so we already covered the setting to the due mode or begin mode, set to due or set to the begin mode in the calculator.